Okay, so many of you have dealt with absolute value before. What is it? What is it that you know about absolute value? Give me anything that you know. Yeah, Yana. Yeah, distance between what and what? Yeah, it's the distance from 0 on what? On this thing that's called what? What do we call it? Yeah, spit it out. On the number line. Very good. You got it. That's exactly what it is. It's this distance from 0 that's on the number line. So as an example, if I said to you the absolute value of 5, what would you tell me the answer would be? It would just be 5. Yeah, very, very simple, right? But there is another spot on the number line that happens to be 5 units away from 0. What would it be? Yeah, so there are, well, that's funny right there. So the absolute value of -5 is also equal to 5. Notice that both of those are equal to 5, right? So when we draw the number line here, and we put 0 on the middle of our number line, and I say 5 is over here, and I say -5 is over here, I represent this by a single dot at both those locations, right? Because each of those locations are exactly 5 units away from 0. So there are two possible answers, okay? There is the positive answer, which is sort of this one over here, a positive representation and a negative representation that are both 5 units away from 0. Does that make sense to everybody so far? Yeah. All right, so we're going to solve absolute value equation. Absolute value of 2x minus 1 equals 5. Okay, now, like we said before, there are two possible answers, right? So how do you go about setting up an absolute value equation? Rachel, what do you do? Exactly. So you go off in two different directions here, and this is how I represent this in my way of showing you the notation here. You go off in two different directions, and those directions are the positive direction, which means 2x minus 1 is going to be 5, by meaning putting a positive 5 there, or the other direction that we're going to have is 2x minus 1 is going to be equal to -5. So notice that there's no longer an absolute value sign in either one of those two equations I set up. Does that make sense? And then we just solve as we normally would. So 2x must be 6, so therefore x has to be 3. Did I do that right? Did you guys get that? Okay, good. On the other side, I'm getting this. I'm getting 2x must be, what, -4, right? So x has to be -2. Do you guys agree with that as well? All right, so I have two answers here. How can I check to make sure that these are actually right? What would I do to check? And it's a good thing to check. Yeah, what would I do? To see if they're equal distance from where on the number line? No, not 0. From what? Taking a number, doubling it, then subtracting 1, right? That absolute value has to be 5 units away from whatever number that is. So there's a different way we can check. What else can we do? Plug it back in. That's the easiest way to do it, right? So here's what we're going to check. The absolute value of 2 times my value is 3, and then minus 1. I want to make sure that that is equal to 5. So look what I'm getting here. Absolute value of 6 minus 1. Does that equal 5? Yep. The absolute value of 5 is still equal to 5. That is absolutely true. That's a true statement, right? What's the other one I should check? Yeah, so here we go. 2 times -2 minus 1. That has to be 5. So absolute value of -4 minus 1 has to be 5. And look what I get here. Absolute value of -5 is also equal to 5, which is also a true statement. So therefore, both of these solutions work. Both of these make it true. So that would be a case where two answers can actually work. What is the thing I'm trying to avoid? What am I trying to avoid when I'm checking? Did anybody know? Yeah, I'm trying to avoid this. The absolute value of like 3 is equal to a -3. Why am I trying to avoid this? Yes, whenever there is a negative sign on the opposite side of my equal sign here, if you were walking down the street and I said, what's the absolute value of 3? What would you tell me? If you were walking down the street and I said, what's the absolute value of -3? What would you tell me? Also 3. You would never say this number, would you? In a sentence to anybody. So that's what we're checking for to make sure that we're not getting that. And we did not get that in either case here nor here. Okay, please try this one on your own. Think about it, show all your work, get your answers. Talk to somebody next to you, say, hey, what did you get? This is what I got. I'd like you to Solve it, check it, and graph it. So solve it, check it, and graph it. Do those three things, okay? Okay, so we're looking at x was negative 2/3, x was a negative 2. We checked. Both of them gave us true statements here, and here, and how do you go away? Okay. Alright, this one. Okay, we also checked and we got that. So on the number line, how do you graph this? I only need 3 points on this number line. What do you think one of the points I need is? Yes, Isabel. 0. Yes, I need 0. Put 0 somewhere on the page, right? Okay, then what's the other point I need? Mia. 2/3. Now, is that to the right of 0 or to the left of 0? To the right. Somewhere on the right, give me a 2/3. I don't care where it is. Just give me somewhere on the right at 2/3. What's the other point you need? Yeah. A negative 2 now. Is that to the right or the left of 0? That's the left, so it's a little bit more than 2/3, so I'll go over here. Right? So here we go. I need a point here, and I need a point there. That's how we graphed it. So we solved it, we checked it, we graphed it. Can you do all three of those things? Okay, this will be a funky example. What should we do first? Who's got a good idea? Yeah, Rachel, what do you think? Multiply the whole right side by a negative 1? Yeah, that definitely has something to do with it, right? Well, let's just treat it like we would the other way, right? Let's just go the positive direction. Let's go the negative direction. And there's your negative 1, right? So that is going to be part of it. So we're going to have this. We're going to have 3x plus 2 is the positive of 4x plus 5. And the 3x plus 2 is the negative of 4x plus 5. Or, as Rachel said, multiply the right side by a negative 1 on this side, which makes total sense, okay? So let's solve the left-hand side. I'm getting 3x plus 2 equals... Oh, I should have just done something there, huh? Equals a 4x plus 5. Okay, what should I do? Looks like negative 3 is equal to x. Do you guys get that? Yeah. Oh, sweet. So x is just negative 3. Okay, I like that. On the right-hand side there, I'm going to get 3x plus 2. This should be equals, yeah? Equals, how about negative 4x and then minus 5? You guys agree with that? What property did we just use right there? The distributive property. You're totally right. Okay, so then if I add 4x to both sides, I'm thinking 7x is now going to have to be a negative 7. Is that true? Then dividing by a 7 on both sides, I'm thinking x must be a negative 1. Okay, so how many solutions have we come up with here? We've come up with 2. All right, we better check these to make sure that we're doing everything good. So let's go ahead and check. So when we check, I'm going to take negative 3 and say 3 times negative 3. And then I add 2 to that. And 4 times negative 3 plus 5. Okay. So let's see here. This looks like negative 9 plus 2 is equal to negative 12 plus 5. So the absolute value of negative 7 is now equal to, I'm getting a negative 7 out of this. Okay, it's wrong. Alarms are going off in your head. Why is this wrong? Yeah, because we know that the absolute value of negative 7 can only be one answer, right? 7 or 7. Can't be anything more than that, right? Yeah. So the absolute... That was a joke. It's a bad joke. Okay. Okay, so if you were walking down the street and I said, hey, what's the absolute value of negative 7? What would you tell me? You would say 7, wouldn't you? You would not say this answer right here. Do you know what that means? That means that x equals negative 3 is what's known as an extraneous solution. Okay, this word extraneous solution. What that is, that's a solution that's generated by algebraic properties, right? Division algebra, the division property, the addition property, all these legal algebra properties that we're allowed to use to get to the answer, but doesn't fit the context of the situation, okay? So sometimes these pop up and you have to check. So in this case, the only answer that might work would be negative 1. So if we check negative 1 now, we get this. Absolute value of 3 times negative 1 plus a 2. Is that the same thing as a 4 times a negative 1 plus 5? Is this statement true? Well, this is a negative 3 plus 2. That looks like negative 4 plus 5. This looks like absolute value of -1 is equal to, oh look, 1. Is that a true statement, you guys? That's a true statement. So therefore, the only one that will work for us in this particular case is a -1. The other one is called an extraneous solution. So these are the two possible situations that we could have for absolute value inequalities. One of them is a and statement, and one of them is an or statement. Do you remember which is which in either case? Yeah, go ahead. The second one is the and? You sure? Okay, this one right here, right? This is the and statement. Okay, this right here, this is the or statement. Okay, so how do we know which is which and what does it mean? And how do we set them up? Okay, well, if the absolute value of a number is less than, okay, then less than a, then that means that it's sandwiched between a certain spot. And the spot that it's sandwiched between is the actual opposite of that number and the positive of that number. So this is the correct setup for the and statement here. So notice that in that purple box, there's no absolute value bars anymore, right? That's gone away. That's different than this statement over here, right? If we're saying that the absolute value has to be bigger than a number, well, there's two directions that could be, right? We can say, well, x either has to be bigger than a itself, or x is, anybody know what it is? Less than the negative of a itself. Okay? So these right here are the proper setups for absolute value inequalities. Okay, so take a look here. We have the absolute value of 2x minus 1 less than 5. This is an absolute value inequality. So look back up to here so I can put this all together. Which one is this? Is this an and statement or is it an or statement? And statement. This is an and statement. So what's the correct setup going to be for this? How are we going to set this up? We're going to look here. Yeah, -5 is less than 2x minus 1 is less than +5. That's the step that we're going to use. Okay? So we'll go back to full screen so we can work that one out. Now they're the correct setup. Okay, now, what should I do? If I want to isolate x, what could I do everywhere? Juliana? You got it. Add 1 everywhere. Add 1 everywhere. Now we're going to work vertically. -5 and 1, how much, Flo? -4 less than a 2x less than 6. You guys agreed? Okay. Brian, what do we do now? Divide everything by 2. You're totally right. Divide everything by 2. Okay, -4 divided by 2? -2 less than an x less than what? Okay, now, how come I did not have to reverse the direction of any inequalities there? Very good. I never divided by a negative, nor did I multiply by a negative, right? Okay, so now I've solved it. Now we need to graph it. So here's my number line. My number line goes on in infinity to the right and to the left, so put numbers there, or arrows, I mean. Okay, here's 0. What other numbers do I need on my number line? Yep. -2 is over here somewhere, and then a 3 is over here somewhere. Now, above each of those, we're going to put an open dot. Why is the dot open? Yeah.
It's just greater than, it's not greater than or equal to.
It's just greater than, right? We're not including a point. Okay, now, so look what this says, right? We want all numbers. This, when you see this, I want your brain to say this. I want all numbers that are between -2 and 3. That's why it's an and statement. What numbers are between -2 and 3? Well, where do I find those numbers? Those are all right here. Someone give me an example of a number that would fit and make this true. 0, 1. Give me another one. -1. Good. At the same time, give me one that's not going to work. Everybody, go. Good. Did you guys? How many of those are there? There's a lot. Define a lot. There's an infinite amount. Okay. Very good. Okay. So let's go back. Let's think about this. Which statement is this? Is this a greater than or less than, or an and? This is going to be an or statement because we have the absolute value of some stuff is greater than a value. So this is going to be an or statement. Okay. So we'll head back to this now that we know how to set it up. So what's the proper way to set up?
2x plus 4
Yep.
is greater than 6.
greater than or equal to 6, or 2x plus 4 is less than or equal to negative 6. There you go. That setup is quite different than the other setup, right? Would you agree? And what's the biggest mistake students make in the procedural aspect of mathematics? They mix up the procedures, right? They have an and statement and they do it set up like an or and vice versa. So don't be that student. Okay, what do we do? Solve it. Yeah, you got it. 2x is greater than or equal to what? 2? Yeah, so that x has to be greater than or equal to 1. Did I get that right? Is that what you guys got? Alright, and then 2x is less than or equal to negative 10. So x must be less than or equal to negative 5. Does that make sense to you guys?
Yeah.
Okay, awesome. Now, if I'm going to graph this, go a little bit smaller, move it over.
To do the two closed dots.
Yes, here we go. I need a 0, right? There's 0. What's the other point I need?
-5.
I need a 1 over here, and I need a negative 5 somewhere over here. Good. Now, are the dots open or closed? Jake,
Closed.
how come they're closed?
Because it's greater than or greater than.
Yeah, very good. So I want numbers that are bigger than 1. Which direction are numbers bigger than 1?
Right.
To the right. Yes, you got it. So I want all this stuff over here. This is how I do my shading. Or I want what? There's that. Okay. So do you see why this is an or statement, ladies and gentlemen?
So ors never meet in the middle.
Yeah, exactly, right? Because can you think of a number? Can you think of a number that is less than negative 5 and at the same time bigger than 1? No. So and statements aren't going to work in this case, right? But an or statement will, because you get to pick. Well, I can give you one that's less than 5, negative 5, or I can give you one that's bigger than 1, but I can't give you one in between.